Hello, this is Dr. Mears. Today we are going to be going over function notation. Function notation is a quick way of expressing substitution. F of x is said as f of x, and it means f as a function of x. We can also write it another way. We see f of x as f colon and then an arrow. This also means f as a function of f. We can also use different letters to represent different functions. And you're going to see this below in our examples. Number 1, calculate the substitutions indicated for each given function. So a couple things before we start. I do want to let you know that when we have a function, we have the function f, and we have an input. And what we do in a function is we input a number. And when we input a number into our function, we're going to get an output. And a lot of people like to say that our input, which is true, is x, and our output is y. And so we get this ordered pair, x, y. And that's how we're going to be treating our functions, as input, x, and as output, y. So when we have an input, we have an x, and we're going to be looking for the output, which is the y. Part A. G of x, and that's okay because G is just another letter that we can use for f. So this is just the G function. So G of x equals, we have these ordered pairs, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11. What we need to find is G of 8. So what we're doing is we have G of 8, we're inputting 8. And we are looking for the x that is 8. We want to see what that output is, which is going to be the y. And this is how we're going to be treating these functions. So let's go and look to see. All right, which one has an x value of 8? Ooh, this one. X is 8. So what is its corresponding output or y value? 9. And so that is the answer. And this is how you write it in function notation. All right, let's keep going. Part B. F of x equals negative 2x minus 1. Please be careful of these negatives. We're looking for f of negative 3. So we need to input where we see an x, negative 3. So we have f of negative 3 equals negative 2 times, we have an x, so we're going to input negative 3 minus 1. And so what we're going to do is this side in the calculator, or you can multiply. Negative 2 times negative 3 is positive 6, minus 1 is 5. So in the calculator, you could have just put this whole entire side and it would have given you 5. So we input the negative 3 for x and we get an output of 5. F of x equals 3x minus 7. So this is just saying here is our function, f of x. And we want to input f of 1. So we're going to input the 1 into the function 3 times 1 plus 7. When we input the 1, 3 times 1 is 3 plus 7, we get out 10. Just another way to write function notation. Input 1, output 10. Input x, output y. Okay, here we have part D, h of x equals 3. Again, just another letter, just saying this is the h function. So h of x equals 3. We want to input negative 1. So where we see an x, we're going to input the 1. Now, please notice on this side, we just have the 3. We have no other x's. So this is your answer. We can't do anything else because anytime we input any number here, we're always just going to get an output of 3. So this is your answer, and that's what you would write. Okay, next. Part E, looking at a graph. So when we look at this graph, again, we're looking at x and y. So we're going to be inputting f of 4 into the graph. So this is the x. So here is your x-axis. I don't know if you can see that. That is your x-axis. So we're going to go to 4 on the x-axis. And we want to find what the corresponding y value will be. So we go to 4, and we go all the way up or down until we get to the point. The point's right here. And we're going to go, so we're going to go all the way up. Here's the point. Let's find out where we're going to come out of, and that is going to be 5. So we input 4, we get an output of 5. All right, next, number 2. F of x equals negative 3x squared minus 1. Please be careful. This is a negative here, and this x is squared. We need to find all of these values. The first one, if you would pause and try it yourself, that would be great. We have to input 5. So what I'm going to do is I'm going to input 5. Please notice I am using parentheses. This is important for when we have negative numbers. So I'm going to input 5. What you do first for order of operations is you always square it. So 5 squared is 25 minus 1. So f of 5 is going to be negative 76. Okay, next, f of 4, f of negative 4. So we're going to input negative 4, negative 3 times negative 4 squared minus 1. When you do this in the calculator, it is imperative you put the parentheses around the negative as well. Please. You input it into the calculator. Here is my calculator. Negative 3, parentheses, negative 4, end parentheses, squared, over arrow, minus 1, and we get negative 49. Okay, next, f of 0. Again, if you want to pause and try this on your own, input 0, f of 0 equals, this is going to be 0, so negative 1. Next, f of a. Now we're going to see that we're going to be substituting in letters or expressions, and that's fine. So here we're just going to take the x out and replace it with the a. So f of a equals negative 3 times a squared minus 1. I like the parentheses there. You can rewrite it. It's absolutely fine. Negative 3a squared minus 1. That's fine as well because a times a is a squared. So that's just a simpler version. Okay, moving on. Part E. Now, here's the deal with Part E. First, let me write down my function at the top of the paper so we remember what it is. Part E. Some of you in this class may have seen a problem like Part E before in your studies. If you haven't, it is okay. We are going to be getting to a unit where I'm going to be teaching you how to do a problem like Part E. For those of you who have seen it, I implore you, take this challenge to actually work this out and see how much you remember, how much algebra you remember of this problem. So I am going to do it. I'm going to do it relatively quickly because either you've seen it or you haven't. So pay attention, see if you remember it, see if you can do it. If not, again, I am going to come back and revisit this type of problem. So please do not panic. All right, so oops, I'm sorry, I made one. I was talking there. So we're going to input f of x plus 1. So what happens is this entire x plus 1 goes in place of this x. It is squared. So what we're going to have to do is we are going to have to square it. And when we square it, we multiply it by itself. We have to multiply this first. So here's f of x plus 1 equals negative 3. When we multiply this, we multiply, and this is still going to be, we're still multiplying by 3 here. I'm not going to do anything with the 3 yet. When we multiply, we do x times x, which is x squared. X times 1, which is positive 1x. And then, again, I distribute this one. 1 times x, which is another positive 1x, and 1 times 1, which is 1. I now combine like terms. So I have f of x plus 1 equals negative 3 x squared plus, I have 2 of these x's plus 1 minus 1. I now have to distribute this 3 to everything inside. F of x plus 1 equals negative 3x squared minus 6x minus 3 minus 1. I now have to combine this negative 3 and negative 1. So my final itty bitty little answer is negative 3x squared minus 6x minus 4. Okay, again, I am going to be going over this with you. If you remember it, great. If you wanted to take that challenge and you're like, oh, I get it, Excellent, but just stick with me. We're going to be moving on to some word problems, and there are two word problems here. The first one, the formula to calculate the volume of gas left in a car's tank in liters after traveling d kilometers is V of d equals negative 0.115d plus 60. So basically, we're in a car, we're traveling, and this is our equation to see how much gas is left in our tank. That's what this problem is about. So we have to explain what V of 250 represents. So what I like to do here is I like to go back in the problem, I find D in the problem, and then I look to see what it represents. After traveling d kilometers. So traveling d kilometers, so that's distance. So I write it D equals distance traveled. There are two L's in traveled or one? Then what is V? Let's go back. Calculate the volume of gas left. So V equals volume of gas left. Okay, so here, this is where the D was. So D is distance traveled. So I travel 250 kilometers. And so V is the volume of the gas. So V is the volume of the gas. Left in the tank after traveling 250 kilometers. There we go. Okay, always locate what the problem represents. Next, explain what V sub D equals 10 means. So 10 is going to be their output, and output is going to be the volume of the gas left. Volume of gas left in liters. So V sub D is how far the car has traveled when there are 10 liters left. Okay. What values of D do not make sense for this situation? Well, we can't travel negative distances. And we can't go over the number of miles that the car can actually go on a full tank. So just some thinking points here of what limitations we have to distance. Okay. And lastly, number 4, Nikita. Nikita is planning a sports banquet. He must pay $320 to rent the room and $20 per person for dinner. Express C as the total cost as a function of N. So that's how we write C as a function of N equals. All right, so how much must he pay to rent? So he's paying a flat fee of $320. So we know whatever else we're going to buy or whatever other costs, we add on that flat fee of $320. We see we have $20 per times person N. So we have 20N. This is, yes, you're right, this is an actual function, linear function. What notation would be used to find the cost if 125 people? That is N. So we are inputting our N, and we are going to input 125 to the formula, just like we've been doing. So C of 125 equals 2,820. Okay. What notation would be used to find the number of people who can attend the banquet if Nikita's budget for this banquet is $250? So here we have total cost. Total cost is this whole entire side. This is total cost. And remember, this is number of people. So we're going to take out the total cost, 250, and we need to solve for the n. Subtract 320, and we get, oh, I just solved this so quickly. 1250 minus 320 is 930. Divide it by 20, and we're going to get 46.5. So here's the thing, round down. If we round up a half a person, we're going to go over our total cost. So round down to avoid going over cost. Okay, so about 46 can go. And what values of n do not make sense? We can't have negative people. And there's my lights. Woohoo! Lights, lights, lights. There we go. We can't have negative people, and the room can only hold so many people. That's capacity. And that is called capacity. You usually find that on the walls, like this elevator can't hold over 10 people. This room can't hold over 250 people. All right, this has been function notation. This is quick. The bell's going to ring. The lights went out. I hope it helped. Ask me questions. And this is Dr. Mears. Thank you very much.